And another important thing you have to remember is that how the exception level can be updated when you give the power to the system. So when you refer to the reference manual that describes boot sequence, we're going to identify this workflow. In this lecture, we will explore the boot sequence with the concept of exception level 3. So let's understand the main concept of boot sequence. Boot sequence describes detailed steps when the system power on or reset. So it describes how to initialize the basic hardware unit and the basic software, just like bootloader or Linux kernel. So it is responsible for bringing the system into the working state. So if you refer to the reference manual of the chipset vendor, I'm sure that you will identify the contents that describe boot sequence. Take for example, if you refer to the Qualcomm reference manual, you're going to see the boot sequence diagram. Or you can identify the similar, some material that covers boot sequence when you work on the MediaTek-based chipset or some Exynos-based chipset. Now here, let's take a look at the boot sequence diagram. The boot sequence it typically contains the 3 or 4 the basic component. So boot ROM, the first programmable bootloader, and second the programmable bootloader and Linux kernel. Those the 4 component is the primary, some of the initial software component when you give the power to the system. Control is the path from boot ROM to the first programmable bootloader. Then from the first programmable bootloader, the control is transferred to the second programmable bootloader, and the control is transferred to Linux kernel from second programmable bootloader. Please remember that detailed operation of each software component will be explored in the later lecture. Now we have the very important question when you learn about the exception level. That is, what is the initial exception level after power on? The answer is exception level 3. So most of the chipset vendors initialize their first exception level as exception level 3. The biggest reason is exception level has the highest privilege level. It means that it has the full control over all of the hardware resources. So I believe that every time you look into the reference manual of the Qualcomm, some chipset or MediaTek chipset, I'm sure that you're going to see that the first exception level or initial exception level is exception level 3. Now let's look at each component with the notion of exception level 3. So boot ROM is placed onto on-chip memory. That means that the boot ROM is already flashed onto the on-chip memory. So we don't have to, the normal embedded software engineer doesn't have to flash the image of the boot ROM. So boot ROM has the basic initialization assembly block to initialize the hardware unit, such as PMU and clock controller and so on. So assembly routine inside boot ROM is very simple. So here is the typical example of the code inside boot ROM. And then when the boot ROM is starting to execute, so each exception level is exception level 3. Because when the software accesses the hardware resource, it has the full control over all of the hardware resources, such as system register or any kind of access to the memory address. Once the boot ROM initializes the basic initialization of the hardware unit, and it loads the image from the storage device like the eMMC or the UFS, and then it makes the programmable bootloader to be executable. That is the main job of the boot ROM. So control is transferred from the bootloader to the first programmable bootloader. So at this moment, what is the exception level at this moment? The answer is exception level 3. So most of the first programmable bootloader is running at still exception level 3 because at this stage, more initialization of the hardware unit and software component should be performed at this level. So we initialize the PMU or fundamental basic unit of GPIO or UART, PMIC, and so on. So at this stage, even the DRAM is not initialized. So most of the chips describe that the bootloader is running at the on-chip memory instead of the physical DRAM. So right after initialization job is done, in the bootloader, it will load the image of second, the programmable bootloader, and make it executable. So that is the job of the first programmable bootloader. Remember that initial exception level, the bootloader or the bootloader is exception level 3. So most of the system register that is accessible at the exception level 3, so it can be initialized at this stage. Now that you got to know about the first initial exception level during the boot sequence, the next lecture will explore about the second programmable bootloader with the concept of exception level 2.